Hey everyone, today is an asynchronous day, so you're going to watch this video, you're going to take some notes, and then you're going to work on some classwork that I have assigned to you guys on Google Classroom. All right, so today you will be working on factoring using the greatest common factor. There is no warm-up. You're going to take notes, we're going to do practice problems. Whatever you don't finish from the classwork will be your homework. And techniques for solving quadratics and mechanics of factoring will be applicable and necessary in Math 3. So this lesson is super, super important. All right, so let's talk about factoring first. So factors are numbers we can multiply to get another number. So for example, 3 times 4 give you 12. That means 3 and 4 are factors. A number can have many factors. So 3 times 4 aren't the only multiples that give you 12. The other factors of 12 are 1, 2, 3, 4, 6, and 12. Now, because 1 times 12 is 12, or 2 times 6 is 12, or 3 times 4 is 12, that list of numbers are all factors of 12. Now, there's something else called common factors. So let's say we worked out the factors for 12 and 30. We just talked about the ones of 12, but if you broke down 30 and you looked at all the factors of 30, and remember, these are not just the prime factorization, but all factors of 30, you would see that that's 1, 2, 3, 5, 6, 10, 15, and 30. The common factors are 1, 2, 3, and 6, because those are the ones that you see in each factor. So for example, you see 1 in both, 2 in both, 3 in both, and 6 in both. That's why those would be common factors. So go ahead and pause this page, or pause the video and copy this page down. All right, let's go ahead and continue. So let's talk about the greatest common factor now. So the largest of the common factors would be the greatest common factor, or GCF. In our previous problem for 12 and 30, here are the common factors we came up with. So again, we came up with 1, 2, 3, and 6. Those are the common factors. Now, out of those common factors, the greatest common factor is 6. So the greatest common factor is a factor that two numbers have in common, and it's the biggest number. When factoring, always look for a GCF, greatest common factor. If you have a GCF, you must factor it out first. So today we're going to be working on factoring polynomials, and we're going to try to factor out that greatest common factor out. Go ahead and pause this video here and copy this page down. All right, you guys, let's go ahead and get into some practice problems. So here we have the first 4 examples. So you want to factor out the GCF. You have 2x plus 10. So here we have two terms. We have 2x and 10. Look for the greatest common factor. So I'm looking at 2 and 10. The greatest common factor between those numbers is 2. So I'm going to put that GCF is 2. And then what we're going to do is factor that GCF out. Now I'm going to show you the way that you can show your work on these. So I'm going to go ahead and divide them both by my GCF. Okay, so you're going to divide them each by the GCF. You're going to write whatever you're left with. So you're going to go ahead and divide. 2 divided by 2 goes away. It gives you 1. And you're left with x. Keep your sign. 10 divided by 2 gives you 5. You want to put that in parentheses and put your GCF on the outside. It does not disappear. This is not an equation. It doesn't go away. So your answer is 2 times x plus 5 would be the factored version with your GCF on the outside. So again, your GCF always goes on the outside. All right, let's try another one. So the next one we have 3x squared minus 9. So again, we're going to look for that GCF. GCF for this one is 3. Okay, I have two terms. If you look at both of those, they both have a 3 that I can divide out. For now, ignore your variables. So let's go ahead and divide that 3 out. The reason we're ignoring our variables is because there is also no common factor between the variables, and we'll talk about that a little bit later. So go ahead and divide. 3 divided by 3 is 1. So just write whatever you're left with. We're left with x squared for our first term. Bring down the minus. 9 divided by 3 is 3. Throw that in parentheses. Put your GCF on the outside. So this answer is 3 times x squared minus 3. All right, let's go ahead and try the next example. So for this one, go ahead and find your GCF. This time we have 1, 2, 3 terms. So look at each term, think of what's my greatest common factor. Okay, I have 2, 8, and 4. The greatest common factor is 2. So I'm going to divide that 2 out. All right, so go ahead and divide. 2 divided by 2 is 1, so you're just left with x squared, plus 8 divided by 2 is 4, bring down that x, and then 4 divided by 2 is 2, and that's a plus sign in between. Throw that in parentheses, put your GCF on the outside. So here is my answer to number 3. The last one on this page is number 4. So again, we have 1, 2, 3 terms. This is a trinomial. Let's think of our GCF. Okay, so we have 6, 8, and 4. Our greatest common factor for this one is 2. Okay, 2 is the biggest number that is divisible into each of these, is a multiple, I'm sorry, into each of these. So let's go ahead and divide by 2. Okay, 6 divided by 2 is 3, bring down the x squared y, plus 8 divided by 2 is 4, bring down the x, plus 4 divided by 2 is 2. Put that in parentheses, leave the 2 outside. Okay, so here are some examples on factoring out the greatest common factor. All right, let's move on to the next page. So here are some more examples. Now this time it's a little more challenging because you can also factor out some variables. So let me go ahead and show you what I mean. So let's look at number 5. We have 2 terms. We have 16p to the 4th power and 4p to the 3rd power. Now, when we're looking at our GCF, you're thinking of, okay, what's the greatest number that 16 and 4 are divisible by? So if I'm looking at my GCFs for those are 4, okay? Because 16 is divisible by 4. 4 is also divisible by 4. It's the greatest common multiple, okay? So that means it's the greatest common factor. So I'm going to go ahead and write 4. Now, the other thing that's interesting about these that we did not have last time is we actually have the same variable for each term, okay? That means that I actually, and I'm just going to show you a visual, p to the 4th just means I have 4 p's multiplied here. That's what p to the 4th means. For p to the 3rd, that means I have 3 p's that are multiplying. So remember that when you're thinking of a greatest common factor, you're thinking of the largest number that you can factor out. So here I can actually factor out 3 p's from each. That's the most I can factor out. I cannot factor out 4 because I don't have enough here. Okay, I only have 3. I could factor out 1, I could factor out 2, but the greatest would be 3. So I'm going to put 4p to the 3rd power is my greatest common factor. So I'm going to go ahead and divide by that, by 4p to the 3rd to each term. Okay, and this up top is just a visual representation. You don't have to do that with every problem that you have. Okay, so let's go ahead and simplify this. 16 divided by 4 is 4. Be careful with your p's. So I took 3 out. I divided 3 away, so you're left with 1p, or p to the 1st power. Plus, right, 4 divided by 4 is 1, so it's gone. You took all 3 p's out. Okay, so that means you're not left with any. So this is just a 1 right here. It's the 1 from 4 divided by 4. No p's, so you shouldn't have a p to anything. And then this is your answer. Just make sure you put it in parentheses and put your GCF on the outside. So 4p cubed. Okay, and again, your GCF goes on the outside. We're going to do that again with number 6. So for number 6, you have 9x plus 36. So again, let's think of a GCF. Now this time, I have an x here, but I don't have any x's there. That means I can't factor any x's out. You need to have them in both terms. It needs to be a greatest common factor for each. So I'm not going to factor out a variable. I'm just going to factor out a number. In this case, I'm factoring out the number 9. So I'm going to go ahead and do the same thing. Divide by your greatest common factor. Write what you're left with in parentheses. So 9 divided by 9 is gone. It's just 1. Bring down your x. Plus 36 divided by 9 is 4. So bring that 4 down. Your GCF goes on the outside. So you're done with number 6. That one was pretty easy. It's a little easier when you don't have to factor out a variable. For number 7, you do. So if you look at that, you actually have the same variable. You have n to the third and n to the fifth. So let's go ahead and think of our GCF. So we have two terms. Our GCF, as far as the number goes, it's 3, okay, because 6 and -3, or just 3, are both divisible by 3. And then n to the third and n to the fifth. So for those, the greatest thing I can factor out of both is n to the third power. Because remember here, I have 3 n's multiplied, and for the second one, I have 5. Okay, so I can only take out 3, okay, from each. So you need to make sure that you can take out that many. I can't put something like n to the fourth because I wouldn't have enough with my first term. So let's go ahead and write down what we're left with after we divide. So let's divide each term by our GCF, 3n cubed. All right, let's go ahead and simplify. So let me use a different color. 6 divided by 3 is 2. Now n to the third divided by n to the third is gone. You took all the n's out, you're done. Minus 3 divided by 3 is 1, okay? And then n, okay, so I only took out 3, I'm left with 2, so this is n squared. Now here's another trick. Oops, sorry, I forgot to put my GCF on the outside. Shame on me. This is going to be 3n cubed on the outside. Okay, so that's my answer for that one. Now, I'm going to show you another trick you can use. You can actually subtract. So you might end up having really big numbers in the future. You could subtract your powers. So 5 minus 3 gives you 2. 3 minus 3 gives you 0. That's why we don't have any here. Okay, so you can do that as well. Just a trick for you. All right, let's move on to the last problem. We have 9x to the 7th power, y to the 5th minus 3x squared, y to the 6th. So this looks like a handful, but again, we're doing the same thing. So let's think of a GCF. We have two terms. As far as the number goes, it's going to be 3. And this time, we have two sets of variables. We have x's in each. We also have y's in each. So that means I can factor out x's and y's. As far as x's go, I can factor out 2. So that means that's x squared. And as far as y's go, I can factor out 5. Let me color code this a little bit better for you. I can factor out 5. Okay. Let me give you a visual really quick to show you why. So for my x's, I have 7 here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yes. And then 5 y's. So 1, 2, 3, 4, 5. Oops, those are not y's, those are x's. Hold on. 1, 2, 3, 4, 5. And then for my second term, I have 2 x's and 6 y's. 2, 3, 4, 5, 6. So remember, if I'm taking out the same thing from each, because we need to be fair, I can only factor out 2 x's from here, means I'm going to factor out 2 from there. And then for my y's, I can factor out 5 here. That means I can only factor out 5 here. I can't factor out more than 5 y's because I wouldn't have enough with my first term. Okay, I can't factor out more than 2 x's because I wouldn't have enough with my second term. That's why I picked those numbers. Now, you could technically only factor out 1 x, but remember, we're thinking of greatest common factor. So we want to factor out the greatest number possible. Okay, let me move this hot mess over. Up there. Okay, let's go ahead and divide. So I'm going to go ahead and divide by my greatest common factor. So 3x squared y to the 5th, 3x squared y to the 5th. Now that greatest common factor is going to go on the outside. So you can get that ready, open up your parentheses, and then you're going to write what you're left with. 9 divided by 3 gives me 3, and then subtract your powers. 7 minus 2 is 5. So that's 5 x's left. Subtract your powers. 5 minus 5 is 0. That means Those y's are gone. So you don't have to write a y. Bring down your minus sign. 3 divided by 3 is 1. So you don't have to write it. Unless you're not left with anything, then you would put a 1. But for now, I'm not going to write it. Your x's, subtract your powers. 2 minus 2 is 0. That means they're gone. You don't write an x. And then our y's, 6 minus 5 is 1. So that's y to the first power. So this is my answer. Let me bring that parentheses in so it's not so far away. And then if you have something to the first power, you don't have to write it. So I'm just going to take that 1 off. But this would be my answer for the last problem. So again, this is factoring using the greatest common factor. I have a couple more examples, but those involve difference of squares. So sometimes you may have a difference of squares, but it's easier to factor once you pull out that greatest common factor. So remember that for your difference of squares, they're in this format where you have an a value, you have a b value that are subtracted and can be written as perfect squares. You can rewrite that as a plus b and a minus b. So you could rewrite that as two linear factors. We're going to do that with number 9 and number 10. So before we write it as a difference of squares, and it should be obvious why it's a difference of squares. You have a square here and a square here. You have a subtraction sign. I can actually factor out a 3. So I have a GCF that I can factor out. I'm trying to erase this arrow and it's not erasing. Let's see. It doesn't want to go. That's fine. We'll write over it. So our GCF here is 3. I cannot factor out an x because I only have an x squared here. I don't have one for my second term. Same with z. I have a z in my second term, but I don't have one in my first term, so I can't factor it out. It needs to be something that they each have in common. Okay, so let me factor out the 3. Let's see what that does. So remember, it goes outside. It does not disappear. You don't have an equation. Okay, so 3 divided by 3 is 1. It's gone. You're left with x squared minus 3 divided by 3 is gone. You're left with z squared. Now this inside portion is exactly what we see up at the top. It's a difference of squares. So I'm just going to pay attention to the inside. My a value is my x. My b value is my z. Okay, so if you need to write it down, you can. You don't have to. A value is, x. My b value is z, according to my little formula up at the top. And then what we're going to do is we're going to go ahead and plug in. So leave that 3 outside. You're going to have 2 sets of parentheses for your difference of squares. One's going to be a minus, one's going to be a plus. Your a term is going to go first. Your b term is going to go second. So let's just plug in. So we're going to have an x in the beginning, a z at the end, and you're done. This is factored. Okay, so notice how we used a GCF first, and then we factored out. Okay, for number 10, you have a squared minus 49b squared. Now, if you want to try to factor out a GCF, in this case, you don't have one, okay? So a squared is my only term at the beginning. I don't have an a squared or anything with an a in my second term. So I actually can't factor anything out. So I'm just going to go ahead and apply the difference of squares. But before I do that, I'm going to write 49 as a square. So let me do that. A squared minus 49 is a perfect square, so I can rewrite it as 7 squared, and then b squared. Bring that down. I'm going to rewrite the second portion as one term. So this is 7b squared. Remember that if you have 2 terms and they're both squared, you can take those 2 terms and put them together, put the squared on the outside of parentheses. Now I have an a and a b. So remember, your first term is a, second term is your b. Okay, so I'm going to go ahead and identify my a value, identify my b value. My a is actually a here because that's the variable. My b is 7b. So I'm just going to go ahead and rewrite this as a difference of squares. One's going to be minus, one's going to be plus. Red number goes second, green number goes first. Okay, and then just plug in. So it's a minus 7b, a plus 7b. So factoring out a GCF, a greatest common factor, could be helpful when you have a difference of squares. I know we talked about difference of squares in a previous lesson, but this is how you can make this process a little easier, okay? All right, so classwork. I assigned some classwork to you guys on Google Classroom. You need to do this on a separate sheet of paper, and you're going to upload the work shown that you completed onto Google Classroom. If you don't finish that, that's due this Sunday by 11:59 p.m., so make sure you get that done. And that's it for today. If you have any questions, send me an email.